Okay, I am going to be doing page 49, question 6. It is talking about an open box with no lid, made out of a square piece of paper that is 48 centimeters squared, so 48 by 48. And we're just going to fold up each of these sides. So we're just going to cut a little square, so they're all equal. We don't know how big they're going to be, but some value x. And then we will fold each of those little sides up and we will get a box. And what we're wanting to do is maximize the volume. So find the volume of the box that has the biggest capacity. So maximize the volume. So if these are each getting folded up x, then once I've kind of got my little box here, this height is going to be x, and these lengths are going to be 48 minus 2x each. This length here is 48, take away x, take away x. Yep, so my volume, I know, is my base times my depth times my height. So the base is 48 minus 2x, and this is the same. These are the same. It's a square box. And times the height of x. So when we're multiplying this out, you lot, please write it out properly because I know what you like. So we are going to go 48 times 48, which gives me 2,304. I did that earlier. 48 times 2 is 96x, and then that's going to be minus 96x plus 4x squared, and all of that is times by this x still. So this will be 2304x because I'm timesing the x in now. 96 minus 96 is minus 192 x plus 4x cubed. So I've just added those two, which gives me minus 192x, and now, sorry, I've multiplied by that x, so it's x squared. Okay, so I have multiplied everything out by this x, pretty much. So I am now going to find dV, the change in volume with respect to the side. So as x is getting so from 0, and as it's getting higher sides, how is that volume changing, if you can imagine that? So we are going to differentiate because that is the rate of change. The derivative, change in volume with respect to x, is the rate of change of the sides. So 2304, this would be I did 384 x, 2 times 192 is 384, and 4 times 3 is 12x squared. Hope you're happy with that. And I am finding the maximum, so I am going to let that equal 0. So luckily for us, 12 actually factorizes out, which is very handy, and I get 192 minus 32x plus x squared equals 0. Now if I divide this by 12 and this by 12, that all cancels and I don't have to worry about that 12 anymore, and it just makes this easier to factorize. Of course, you could always put up your trusty calculator and work that out as well on there. Okay, so this is if you just look at this, I'm just going to write this out as x squared minus 32x plus 192, just so that it's the right way round, so that you can kind of, so I'm going to put the x's first, and this actually turns out to be 24 and 8. So 24 times 8 is 192, and minus 24 minus 8 gives me minus 32. So you could have done that with your pairs over here, or just chuck it in your calculator and you will see that it's 24 and 8. So x equals 24 or x equals 8. So just basic factorization. It's equal to 0. Generally, if you've got a quadratic equal to 0, you're going to factorize two things times together to give you 0. One of them must be 0. So there you go. Okay, now if I substitute 24 back into my original equation, 48 minus 24 times 2, it gives me a side length of 0. So that would just be the surface area. So that would actually be a minimum. If you look at this, if you look at my original equation here, it is a cubic. It's an increasing one, so it's doing that. We actually have a 0 and a, yep. So we are, the first one is 8, the second one is 24. So the first one is at 8, the second one is at 24. This is a minimum, that's where it's 0. Okay, so subs into original to check. So it was 48 minus 2x. I'm just taking my base. Okay, so 48 minus 2 times 24 equals 0, so we're not going to use that one. And the other one is 48 minus 2 times 8, which is 48 minus 16, which gives me 32. So dimensions, 32 by 32 by 8, and the volume will just be all of their times together, 32 times 32 times 8, which gives me 8,192 centimeters cubed. Okay, done. Hope that was helpful.